In this tutorial, we're going to look at how you define thermal bridges in the model. Thermal bridges are elements of the building's fabric with a significantly worse energy performance than the general material. So an example might be a concrete lintel over a window, or some kind of steel fixing which runs all the way through a wall. In low-energy buildings, thermal bridges can be a significant source of energy loss, so if at all possible, you should design them out. But if you can't, there are some options to define losses through thermal bridges in the spreadsheet. So this is what the thermal bridges sheet looks like in the model. This gives us an option to define linear thermal bridges, like a lintel, for instance, or point thermal bridges, like steel fixings, through a wall. In both cases, we can define there are no thermal bridges, so we can say there are no linear thermal bridges, there are no point thermal bridges. But if we do have thermal bridges, we define first a loss through that thermal bridge. In the case of a linear thermal bridge, that's a loss per meter. We define the length of the thermal bridge. So if we're defining a lintel over a window, this would be the total length of all the lintels. And similarly, for a point thermal bridge, we define the loss. This is the loss just through that point. And then the number of points, so for instance, the number of those steel fixings through a wall. Once we've done that, we'll have a summary of the flow through thermal bridges for space heating and for space cooling. They'll be broken down by linear or point thermal bridge and by months of the year. If we have no specific values for thermal bridges, but we know our design isn't thermal bridge free, we can apply just an approximate value, which is based on the area of the building fabric. We can go to the calculator here. And SAP 10.2 recommends that for each square meter of building fabric, you allow for a thermal bridge loss of 0.2 watts per Kelvin. So this calculator will just import your wall, ground floor, and roof areas and give you a thermal bridge loss. And what we can do is copy and paste that just as a single point thermal bridge. And that's effectively using the point thermal bridge to define total thermal bridges losses through all the fabric. Like for some of the other building fabric input sheets, if we can increase the complexity level, we don't actually have any additional inputs to define, but it does give us more detail on the calculations that it's completed. So that's an overview of how we define thermal bridges in the Zebra model. In the next tutorial, we're going to look at defining glazing.